So for this semester we are having operation research paper, that is Unit 1, Transportation Models and its Variants. The definition of the transportation model and non-traditional transportation model, transportation algorithm, the assignment model. Unit 1, the definition of the transportation model. The transportation model is a special class of linear programming problem. We call it as LPP. It deals with the situation in which the commodity is shipped from sources, that is factory, godown, to destination warehouse. The objective is to determine the amount shipped from each sources to each destination that minimize the total shipping cost while satisfying both supply limits and the demand requirements. Always we need the total supply equal to total demand. The general problem is represented by the network. That is, the transportation problem can be represented by the network. There are m sources and n destination, each represented by a node. The arc represents routes linking the sources and the destination. The arc I, j joining the source I to the destination j carries two pieces of information. The one is transportation cost per unit Cij and the amount shipped. Second one is the amount shipped Xij. The amount of supply at source I is Ai. We denote it as Ai. The amount of demand at the destination J is Pi. The objective of the model is to determine the unknown Xij that will minimize the total transportation cost while satisfying all supplies and demand restriction. Here these are the sources and here these are the destinations. We denote each source by Ai, that is the first one is A1 and second one is A2, etc. The n source is denoted by An. Here the destination, first destination is denoted by B1 and second destination is denoted by B2, third one is denoted by B3 and etc. The last mth destination is denoted by Bm. Here the arc represents the linkages between the source and destinations. That is here the source 1 to the destination 1. We denote it as X11 and C11. Here there is no arc between, there is no linkages between A1 and B1. Here A1 to B2 we have arc. So A1 to B2 represent the arc, that is the A1 from the supply A1 to demand B2. We are having amount shipped is denoted by X12 and the cost of transportation is denoted by C12 and the source A2 and destination B1. Here the cost of shipping per unit is C21. That is second source to first destination, we denote it by C21 and the amount shipped is denoted by the second one to first destination is X21 and the amount shipped from the transportation cost per unit is from A2 to B3 is denoted by C23 and the amount shipped from A2 to B3 is X23. So, and the destination AN to source AN to destination B2 is denoted by CN2 and amount shipped from AN to B2 is denoted by XN2. Here AN to BN, the amount shipped is XN, M and the transportation cost per unit from AN to BN is denoted by CN, N. So the transportation problem represented by this type of network. Now the balanced and unbalanced transportation model. When the total supply does not equal to the total demand, the transportation model is said to be unbalanced. If the model is unbalanced, we can always augment it with a dummy source or dummy destination to the restore balance. That is, always you have to check it at the total demand and total supply are equal or not. If it is not equal, then the model should be balanced for using dummy source or dummy destination. For introducing the dummy source or dummy destination. The transportation algorithm. The transportation algorithm follows exact step of the simplex method. That is, where we have to use transportation algorithm only for the balanced transportation model. Therefore, if you have unbalanced transportation model, then you can balance it introducing the dummy source or dummy destination. The transportation algorithm follows the exact steps of the simplex method. However, instead of using regular simplex table, we can take advantage of special structure of the transportation model of organize the computation in a more convenient form. Next, transportation algorithm. The transportation algorithm, we have 3 steps. The first step is determine a starting basic feasible solution and then go to step 2. Then in step 2, use the optimality condition of the simplex method to determine the entering variable from among all the non-basic variable. If the optimality condition is satisfied, then we can stop. Otherwise, go to step 3. That is, first determine the starting feasible solution and go to step 2. Here the optimality condition is checked. If the optimality condition is satisfied, then we can stop. Otherwise, we can go to step 3. Use the feasibility condition of the simplex method to determine the leaving variable from among all the current basic variable. Find the new basic solution. Then return to step 2. Then we can check the optimality condition, then we can follow this rule. If the optimality condition is satisfied, we can stop. Otherwise, go to step 3. So, we repeated this step 1 for till the optimal solution is. Next, determination of starting solution. The special structure of this transportation problem allows securing a non-artificial starting basic solution using one of the 3 methods. The first method is northwest corner method. We can call it as northwest corner rule. Least cost method or matrix minima method. Third one is Waggle approximation method. Using these 3 methods, we can calculate the starting basic feasible solution. And then we can check the optimality condition for transportation problem. The difference among the 3 methods is quality of starting basic feasible solution they produce, in the sense that the better starting solution yields a smaller objective values, because our objective is minimize the transportation cost. In general, the Waggle approximation method yields the best starting basic solution, and northwest corner method always yields the worst result. The northwest corner method. The method starts at northwest corner cell of the table. First step 1. Allocate as much as possible to selected cell and adjust the associated amount of supply and demand by subtracting the allocated amount. Step 2. Cross out the row or column with 0 supply or 0 demand to indicate that no further assignment can be made in that row or column. If both row and column net, row net and column net to 0 simultaneously, cross out only one and leave 0 supply or 0 demand in the uncrossed out row. Step 3. If exactly one row or column is left uncrossed out, stop. Otherwise, move to the cell to the right if the column has just been crossed or one below. If the row has been crossed out, then go to step 1. That is, allocate as much as possible to the selected cell and adjust associated amount of supply and demand by subtracting the allocated amount. You choose the northwest corner cell of the table and allocate the amounts supply or demand by subtracting in supply and demand by replace the supply and demand by subtracting the allocated amount. Cross out the row or column with zero supply or demand to indicate no further assignment can be made in that row or column. If both row and column net to 0 simultaneously, cross out only one and leave a zero supply or zero demand in the uncrossed out row or column. If exactly one row or column is left uncrossed out, stop. Otherwise, move to the cell to the right if the column has just been crossed and the one below if the row has been crossed. Go to step 1. So, we repeated the step until we get a basic feasible solution. Least cost method. The least cost method finds letters starting solution by concentrating on the cheapest route. Finds a better starting solution, not a letter. Concentrating on cheapest routes. The method starts by assigning as much as possible to the cell with the smallest unit cost. That is, from the table, we can check it row wise and column wise and find the smallest unit cost cell, and then we can assign as much as possible to the cell. Next, satisfied row or column is crossed out and the amounts of supply and demand are adjusted accordingly. In both row and a column are satisfied simultaneously, only one cross out the same as in the northwest corner method. Next, look for the uncrossed out cell with the smallest unit cost and repeat the process until exactly one row or column is left uncrossed out. Vehicle approximation method. It yields always better starting solution of the transportation problem. That is where VAM means vehicle approximation method is improved version of the least cost method that generally produces better starting solution. For each row or column with strictly positive supply demand are be denoted penalty measures by subtracting the smallest unit cost element in the row or column from the next smallest unit cost in the same row. Once we can check it by column wise or row wise. Identify the row or column with the largest penalty, break ties arbitrarily. Allocate as much as possible to the variable with the least unit cost in the row or column. Adjust supply and demand and cross out satisfied the row or column. If a row and column are satisfied simultaneously, only one of the two is crossed out and the remaining row is assigned zero supply or zero demand. If exactly one row or column with zero supply or demand remains uncrossed out, stop. If one row with positive supply remain uncrossed out, determine the basis variable in the row by the least cost method. Stop. If all the uncrossed rows and columns have zero supply demand, determine the zero basic variable by the least cost method. Stop. Otherwise, go to step 1. Today we are going to see one transportation problem using northwest corner method. It is I will give the link of that class. You can work out with that problems and I will send another 2 more homework for you. Then I will come to the least cost method. Then we have check the vehicle approximation method. Sorry, it is not a matter. Vehicle approximation method only.